Successive division means that a number is subsequently divided by 2 or 3 divisors, but the original number is not divided by all of them. In every step, the quotient of the previous operation is divided by the divisor. For example, say I am dividing say 50 successively with 3, 6 and 2. So how will it go? If you divide 50 by 3, your quotient is 16 and your remainder is 2. Now in the next case, you won't divide 50 with 6 now. You will divide the quotient of the previous operation, 16 with 6. So your quotient will be 2, remainder is 4. Finally, you will divide the quotient of the previous step, 2 by 2. So your quotient is 1, remainder is 0. Alright? So this is what we call successive division. Now successive division, in questions like this, if the divisors and the remainders are given, we can also estimate what the original number will be. For example, say it is given that you divide a number n successively with 2, 3, 5 and 6, and you get remainders 1, 2, 2 and 3, right? Remainders, quotient is not important because there n can take multiple values. So quotient is not that important. We will see that, right? So divisors are given. These are my divisors, of course. 2, 3, 5, 6, and these are their respective remainders. When I divided the number first with 2, then I got a quotient and a remainder. Then I divided the quotient with 3, I got another quotient and a remainder of 2, and so on. So from here I have to estimate the original number. So how do we go about doing that? Okay. We will start with the very last calculation, this 3. I divided by 6, I got a quotient which I have no clue of, and I got a remainder of 3. So it goes like this. Okay, let me write it in a proper way so you understand it better. Say the downward arrow will mean addition and the horizontal arrow will mean multiplication. Okay. Right? Downward arrow addition, horizontal arrow multiplication. Not horizontal in all the cases. Right. So pointing upwards. Okay, these are my divisors, these are my remainders. Alright. I repeat what the whole operation was like. I divided by 2, got a quotient and remainder 1. The quotient was divided by 3, I got a remainder 2. Then obviously there was a quotient in this process which was divided by 5, got a remainder of 2. The quotient of this operation was divided by 6 and I got a remainder of 3. Now how can I estimate my original number? This is how I put my arrows. Remember, the downward pointing arrow indicates addition and the upward pointing arrow indicates multiplication. So it goes like this: 6 plus 3, 9. 9 into 5, 45. 45 plus 2, 47. 47 into 3, 141. 141 plus 2, 143. 143 into 2, 286. Plus 1, 287. Let's check again. 9 into 3, 45. 45 plus 2, 47. 141, 143, 286, 287. Right? So 287, if you divide successively 2, 3, 5 and 6, these are the remainders you will get, right? But 287 is not going to be the sole number which will give us a property, a situation like this. How do I find the next bigger number? It's very simple. Take the product of the divisors. Take the product of the divisors, 2, 3, 5 and 6, which is equal to 180. So all the numbers will be of the form 180k plus 287. So my numbers can be 287 or 180 plus 287, which is equal to 467, or 360 plus 287, which will be 647, or 540 plus 387, which will be 827, and so on. For example, say if the question was, what is the biggest 3-digit number, which will give us a property like that? You can see in this case the answer is 827. Alright. One more case where we can use successive division. You remember in divisibility we said that how do we check divisibility by a composite number? By breaking up it as product of co-prime number. But what if not breaking it up as co-prime number is actually better for us? For example, say I have to check divisibility with 64, right? But 4 into 4 into 4 is not the most appropriate way of writing, as we understood from the divisibility module, because I need to break it up as product of co-prime numbers. But then 64 has only one prime factor, 2. I cannot break it up as product of co-prime numbers. So how can I make my job easy? I can still do divisibility by 4, all the 3 4s. I can use this method. The only thing that I have to keep in mind is I'll have to use successive division. For example, say if I take 5 2 3 5 2 3 2 2 4, say 5 2 0 3 2 4. Right, now this is the number. I need to check till 64. So let's divide it by 4. So what do we get? 1 3 0 1 3 0 56 0 56. Right, now let's again divide. So this is one division. Now let's again divide it by 4. Now this case we will divide the quotient by 4, not the original number by 4. So what do we get here? 3 2 5 1 4. Now is it possible for us to divide it by 4 again? You see the last 2 digits? If we divide the last 2 digits by 4, the number will give us a remainder not equal to 0. So this number is not divisible by 4, which means the original number, it is not divisible by 64. Okay, so successive division can also be used here. Alright, that is more or less what we will do in successive division. Thank you.